In this video, you'll discover how to automate the deployment of machine learning models using C/CD pipelines, a crucial skill for reliable and consistent production deployments. What if I told you that you could deploy your machine learning models into production environments without lifting a finger? Welcome to this tutorial on automating ML model deployment with C/CD pipelines. In today's fast-paced tech world, manual deployments are becoming obsolete. They are error-prone and time-consuming, especially for machine learning models where consistency and reliability are critical. Automation with continuous integration and continuous delivery, C/CD, not only speeds up deployment but also ensures a seamless transition from development to production. Stick around to learn how to set up a C/CD pipeline tailored for ML models, improving your deployment speed and reducing errors. Let's start with the basics. Continuous integration and continuous delivery, or C/CD, is a method that automates the integration and delivery of code changes, enabling more frequent and reliable deployments. In a traditional software development pipeline, C/CD allows developers to automatically test and integrate code changes, ensuring that the software is always in a deployable state. Now, when we speak of machine learning, the concept expands. Here, C/CD not only manages code but also handles data, model training, validation, and deployment. Imagine a world where your latest model version is automatically tested and pushed to production without a hitch. That's the power of C/CD in ML. Real-world examples include tech giants like Google and Facebook, who leverage C/CD to continuously deploy models that power their recommendation engines and search algorithms.
Why should we automate ML deployments? The benefits are multifold. Firstly, it significantly speeds up the deployment process. By automating repetitive tasks, your team can focus on more strategic work. Secondly, it drastically reduces human error. Manual deployments are prone to mistakes, which can be costly in terms of time and resources. Thirdly, automation ensures consistency and reliability, which are crucial for production environments handling live data. With the feedback loop always open, C/CD facilitates continuous improvement, allowing your models to evolve with new data and insights. Additionally, it boosts team productivity by freeing up resources and allowing developers to concentrate on innovation rather than mundane tasks. Think of C/CD as a productivity booster that empowers your ML models to reach their full potential.
Now that we understand the benefits, let's dive into setting up a basic C/CD pipeline for ML models. A typical C/CD pipeline consists of several stages: source control, build, test, and deploy. For ML, we integrate additional components like data processing, model training, and validation. Begin by setting up version control for your code and data using tools like Git. Next, automate the build process to ensure your environment is always up to date. Incorporate automated tests for both code and model validation. This is where tools like Jenkins, GitLab C/CD, or CircleC come into play, helping orchestrate these steps. Finally, deploy your model to a production environment, which could be a cloud service like AWS, GCP, or Azure. Avoid common pitfalls such as neglecting data versioning or skipping validation steps. Remember, a robust pipeline is the backbone of successful ML deployment. Choosing the right tools and frameworks is critical for effective C/CD in ML. Popular C/CD tools include Jenkins, GitLab C/CD, and CircleC, each with its unique strengths. Jenkins is known for its versatility, while GitLab offers seamless integration with Git repositories. CircleC, on the other hand, is praised for its simplicity and speed. For ML-specific needs, frameworks like Mulflow provide a comprehensive platform for tracking experiments, packaging code, and managing deployments. These tools integrate well with cloud platforms such as AWS, GCP, and Azure, offering scalable deployment solutions. When selecting a tool, consider factors like ease of use, integration capabilities, and community support. The right choice depends on your project's specific requirements and your team's expertise. Integrating testing and validation is pivotal in C/CD pipelines for ML. Testing ensures that your models are reliable and perform as expected. Start with unit tests for individual components, followed by integration tests to verify that components work together. Next, focus on validation tests to assess the model's performance on real data. Tools like PyTest, TestNG, and Selenium can automate these processes. Continuous validation is crucial for ML, as models must adapt to changing data and environments. This involves re-evaluating models against current data to ensure sustained accuracy and performance. Remember, robust testing and validation are not just about finding bugs, they're about building confidence in your deployments. Handling model versioning and rollback is a crucial aspect of ML deployments. Versioning allows you to track changes, compare performance, and revert to previous versions if needed. Start by establishing a clear versioning strategy, such as semantic versioning, to label your models. Automate version control using tools like DVC or MoveFlow, which can track data, code, and model changes. Implement rollback mechanisms within your C/CD pipeline to quickly revert to a stable model version in case of anomalies. This ensures minimal disruption and maintains service reliability. Adopting best practices like documenting changes and testing before deployment can further streamline version management, making your deployment process more robust and reliable.
Once your model is deployed, monitoring and logging become essential to ensure it operates as expected. Key metrics to track include latency, throughput, and error rates, along with model-specific metrics like accuracy and drift. Tools like Prometheus, Grafana, and ELK Stack offer robust monitoring and logging capabilities, providing real-time insights into your model's performance. Set up alerts and dashboards to keep your team informed of any anomalies, enabling quick responses to potential issues. Effective monitoring not only helps in maintaining model performance but also in collecting data for future improvements. Adhering to best practices, such as setting thresholds and regularly reviewing logs, will enhance your deployment's reliability.
Let's explore some real-world examples of C/CD and ML to understand its impact better. Take a tech giant like Spotify, which uses C/CD to continuously update its recommendation models, ensuring users receive the most relevant song choices. An e-commerce site like Amazon employs C/CD to deploy recommendation engines that adapt to user behavior in real time. In the healthcare sector, applications like patient monitoring systems use C/CD to integrate updates seamlessly, providing timely and accurate data analysis. These examples highlight the challenges faced, such as handling large-scale data and ensuring data privacy, and the solutions implemented, like advanced monitoring and rollback mechanisms. The lessons learned emphasize the importance of a robust C/CD pipeline tailored to your specific needs, ensuring your ML models are consistently high-performing.
We've covered a lot today. From understanding the basics of C/CD to exploring tools, setting up pipelines, and diving into real-world examples, you've gained a comprehensive overview of automating ML model deployments. The importance of C/CD in ensuring consistent, reliable, and fast deployments cannot be overstated. I encourage you to start implementing these practices in your projects. Explore further resources to deepen your knowledge and stay ahead in this rapidly evolving field. Don't forget to comment below with your thoughts, share this video with peers, and subscribe for more insightful content. Your input helps us create videos that matter to you.